What's up everyone, this is Johnny with JCS Performance. So here we go with a real nice build. This is Vaughn's second motorcycle build. So this is an 88 cubic inch. We're going to make a 124 cubic inch out of it. This is carbureted. We're going to put a 6-speed, some nice exhaust. It's going to be a real nice build. Lots of powder coat. We're going to change the wheels. So we just did our base run so we can start getting ready to take this thing apart. And it did 69 horses, 81 torque. So we're gonna see how much difference we get out of the 124. Now this one we plan to put a little bit more compression than we did on the next one and a bigger cam. So we're hoping for some real good gains. Hopefully you guys enjoy this video, stick around to the end so we can see the outcome on this thing. All right, so here are all the parts we're gonna use on this motor build. So that is a case. Factory case was an 88. We're going to use some S&S flywheels and rods. These flywheels and rods have been balanced and trued, and we're waiting for S&S to ship us the pistons and cylinder kit. We're going to use some S&S oil pump and cam plate, or oil pump cam plate. Some S&S heads that he had previously had on another 107 build, so these have been CNC ported. We're going to still port them some more, open them up. We're going to end up using some 2020 intake valve, 1650 exhaust valve from Kibblewhite, our Kibblewhite springs. We're going to do the cam plate conversion. So what's going to happen is these are our hydraulic tensioners from S&S, S&S push rods and clips, some night prowlers, lifters, S&S oilers. These are a must in every motor build. And then we had Smith Bros make us some custom push rod tubes, push rods. So the reason why we're using these is because we're going to run a lot of spring pressure in a real tall lift on cam. So we're still waiting for the cams to show up from Woods. It's a 0.678 lift. And so because of that, we had them make us some push rods that are a little bit thicker wall. These are a 0.140 wall, which is that thick right there. And on a big motor like this, we like using these. We do use the other ones, like S&S ones, on anything that has like a bolt-in cam or something. But on something like this motor, we like to use some Smith Bros push rods, and they custom make them for us. Anyway, so this is going to be a nice build. We're going to go ahead and start by cutting out the case. So let me get started, and then we'll show you guys the process as we go along. Alright guys, so we're boring Vaughn's case here. So we're boring it so we can put the 4 1/8 big bore kit on here for the 124. So this thing is self-feeding itself. As you can see down there, where it's removing the orange. It's coming out pretty nice. Next step is going to be to press in and out our old bearings, and this one's already been done. It's still a little warm, so I can't pick it up. So what we'll do is we'll put this in the oven, heat this up 350 degrees, and the new bearing has been in the freezer since yesterday morning overnight, so it's pretty cold right now. And so what we'll do is we're going to heat this one up, press the other one out, because that helps out when the case expands, so you don't pull so much material out. So whenever you press in the new bearing, it's nice and snug once it all cools down. So let me get set up, let me take care of that, and then we'll go from there. So here are the cylinders from S&S. This was a 4 1/8 big bore kit for a 4 5/8 stroke flywheel from S&S. So we have the flywheels already installed into the case. We've got our compensator, everything's bolted down, torqued down, so we can check our crank in play. So we're going to get ready to install the pistons with no rings, so we can put the cylinders on, so we can check all piston to piston clearance and cylinder clearance and everything. So I'm going to get set up to do that. So then we'll go from there. Here we have the flywheel already assembled. Pistons are on, cylinders are on, real nice tight fit. And there's the piston to piston clearance is really good. So everything's good on this part. So we're going to go ahead and take it apart and start putting the yummy bond, start getting ready to close the case. And then we'll go ahead and start checking our our ring in gap. All right, so we're gonna take the opportunity to check our piston to cylinder deck height now that everything's out here. So I kind of have it set up already. So we're gonna come down, down, down. Oh, it's already going back. So right there we're 5 thousandths, so the piston is 5 thousandths in the hole, which is nice. It's good. Normally like it in between 5 and 0, just depends. 5 thousandths is good for a good street performance motor. For racing, I guess like a 0 deck would be nice, but for the street, this would be good. So that gives us information, whatever we need to start working on our heads and decking the heads. But for right now, I'm gonna go ahead and install the long block in the frame, and then we'll continue with the rest of the stuff. All right, so we're getting ready to start working on Vaughn's heads. So these were some SNS heads that had been CNC ported. A little bit of damage there that we're going to repair. But I wanted to show you guys our TDC lift. So we're gonna end up using a Woods cam, and the TDC lift is a 0.260 intake and a 0.226 exhaust. So we wanted to make sure that our valves didn't hit, and that's the reason why we're only gonna go with a, let me see, 2.020 intake instead of normally we run a 2.1, and in exhaust we're gonna go with a 1650. So that kind of limits us because of the TDC and the size of our chamber, but we should make it up with the duration. So here's the cam specs. We're gonna do a 678 lift, 268 duration. Of course, that's our TDC there, and then our intake closes at 58. So overall, should sound really good and perform real good. So let me continue with this. Of course, we're gonna use our kibble white springs that we normally use and stuff. So let me go ahead and continue with this, and then we'll show you as we go along. All right, so here we go. Just finished machining the intake and exhaust seat on this head. Gonna start working on this head here. So this is exhaust valve. Look how big our intake port is. Nice. So here is my head sheet that I do on each head. Compression ratio, lift the valve, all the information on the valves. Still need to do my spring pressure and all that stuff, but getting along pretty good on this. So I'm gonna continue and cut this one down so we can start getting ready to start porting these heads. All right, so we're getting ready to start grinding and polishing on these heads. So I just wanted to show you guys how this part is eaten up real bad, and it's because normally your exhaust gets loose and your exhaust gaskets get eaten up, and then your exhaust just wanders in there and bounces around and eats up your head there. So make sure you guys always check your exhaust, make sure they're tight. So let me go ahead and start getting this all grinded down, and then we'll start polishing, and then we can go from there. Right, moving along pretty nice on these heads. So still got quite a bit to go, but here is the exhaust. You can see that little hump right there is mainly all gone. So here is the other head that hasn't been done yet. You can see that little hump right there. To me, it gets in the way to remove the exhaust flow. Same thing with the intake one. You can see it's mainly all gone. A little bit is there to serve a little bit of a purpose to kind of distract or interrupt the airflow a little bit, kind of get it to go that direction towards the spark plug. Here is the other head before we cut it. Of course, this is where we welded it, where it needs to get machined to. But you can see where it's kind of high and really gets in the way of flow. These are CNC heads. They're nice heads, but we like directing the flow a little bit different. So you can see all this part right here. You can see where it's just has a, you know, it's raised part right there and the raised part right there. So here is where it's nice and smooth. Kind of helps out with the flow a lot better. Well, still got quite a bit to go. Just gonna try to work a little bit more on this one and start getting ready to start cutting this one apart. All right, moving along pretty good on the second head. So here is our rough cut. So it's coming along pretty good. Next thing is to start with the cartridge rolls, start smoothing things out, start shaping everything, and then we'll start with the polishing stuff. All right, so we got these heads coming along pretty good. So have a little bit of a polish there on our exhaust, nice and smooth. And that is our intake. So right now it's at 60 grit to help us atomize the fuel when it goes in. So next thing we need to get going and doing right now is going to be to cut the valve seats. After we cut the valve seats, we're going to go ahead and install the spring pressure, or the spring, so we can get spring pressure and spring height. But so the next step right now is going to be to cut the seats. All right guys, just finished cutting the valve seat. So I wanted to show you guys that bottom portion right there, the red, that's our 60 degree, then it's our 45, and then it's our 30. Same thing with the exhaust seat. The bottom part right here is going to be our 60. The part that is actually exposed is our 45, and then the top part would be our 30. We also finished cutting or lapping the valves, and you can see on our intake valve, after we lapped it, is from half down, which is normally what we like on the intake valve. And then on the exhaust valve, you can see where it is mostly in the center. So you can see where it's kind of shiny from here down and it's shiny from there up. So after we lap the valve, it's actually hitting in the center of the exhaust, which is what you want, because the exhaust is the one gets hot and it sends heat through the valve, through the seat, and then through the head and through the fins. You can see right there a little bit of the swirl design on the valve. That's the reason why we like using these kibble whites. Real nice valve. So what we're going to do now is install top collar, lower collar, and our springs, so we can check our spring height. And we're going to have to for sure cut the bottom part of the spring seat, and then after that we'll deck the heads. So we need to check the cc's of the chamber. So let me get started. Let me get set up to do that. All right, so we have this already assembled, simulating like if the spring is installed. So we want to measure from the bottom of the top collar and the top of the bottom collar, and that would be our seated height. And then we need to subtract the difference of the lift, which is a 0.678 in this case, how much is going to come down. So one thing we need to check is make sure that the bottom of this doesn't hit the top of that guide right there. So make sure it doesn't come and hit that. So let me show you right here, kind of rough measuring I did. So the intake seated height is 1.89. The exhaust seated height is a 1.90. It's pretty close. The cam lift on this cam is a 0.678. It's a pretty high lift cam. So if we do a real quick formula, this is a seated height. You subtract the lift of the cam, so it gives us this part number, or this number measurement. And then we need at the minimum a 30 thousandths coil bind. So this is the number we need for the spring to be compressed. And when we compress the spring, we got to make sure that it's not coil bind. That meaning that all the coils are touching, because that would not be good. That can give you pressure on your rocker arm, break your rocker arm, or your rocker arm studs that holds the rocker arm shafts and stuff can break. So then we actually have to remove 30 thousandths from where the lower collar sits, which is this part here. In some cases we need to remove more, but then we also need to be aware of the measurement from here to here, because it only has so much thickness. And if we machine more, we can get into that bottom hole there. So we need to be careful with that. So what I'm gonna do right now is show you the spring on the pressure tool. All right, so right now we have the spring simulated basically if the valve is open at a 0.678 lift. So the measurement is gonna be a 1.242 from here to here, which is from the top to the bottom. And it gives us enough coil bind so the coils are not touching, which is good. And then we also have a valve spring pressure right around 550 pounds when the valve is open. So that's what I talk about a lot of times in my videos, that we run a lot of valve spring pressure. So what we're gonna do next is go ahead and get ready to CC the chicken. All right, so we're gonna get ready and set up to start cutting for the 420 valve seals. You guys have heard me talk about these before. I really like using these. So what we're gonna do is go ahead and show you where when I cut the head. So and here you can see how it made the shoulder a little bit thinner, and then the valve seal is gonna sit in there once the valve goes through the seal. So let me get set up, do the other side, we'll get everything cleaned up. All right, here we go. They're done already. These things came out really nice. Have the valves assembled, our kibble white valves, valve springs, valve seals. So we just finished decking them and washing them, got them assembled. Ports came out real nice. That's your intake port and exhaust port. So next thing is going to be mock them up on the motor so we can check our valve to piston clearance, make sure that we don't hit. It is a pretty big lift, so we got to make sure they don't touch. So that would be the next thing for the heads. But before we do that, we're going to install cam plate and oil pump system. All right guys, so here's the next step. So we're getting ready to install the cam plate, oil pump, of course push rod tubes, push rods. We're going to use some Prowler lifters and our Smith Bros push rods. But what I wanted to show you guys is we're doing a cam plate conversion. So most of the times when you get the SNS cam plate conversion, it's for the older style cams like this one. So this is the 99 to 05 cams. So what we have decided to do is contact Bob over there at Woods Performance, and what we're going to do is from here to back here is the old journal, which is a small bearing, and then from here this way is a new style cam. So we're going to use the cam plate with the bushing and the newer style oil pump. Anyway, we have a video on our Instagram, Facebook, and all that other stuff. If you guys are interested in seeing that, go and check that out too. But we're getting ready to do this part, and then what we're going to do is install our heads, and so we can check piston to valve clearance. So let me get set up, take care of this first, and we can go from there. All right, so we have all this already assembled, installed, checked our clearance. We had to change our cam shim. So next thing is to machine our rocker boxes to clear our valve springs, and just finished that. So now we're gonna get this is in our jig, and we need to machine the ribs to give clearance to our rocker arms, our SNS roller rocker arms, since we're running such a high lift cam. So with the next step, let me set this up, and then we're gonna go ahead and install some clay in the pistons and install the head. All right, so just removed everything, and we did hit here. So our intake valve pushed into the clay quite a bit actually. So we need to go remove the cylinder, piston, put it on the milling machine, and in mill the depth, so you can tell from there to the wall we got plenty of room, but we need to go farther down. So let me get set up, take care of that, and we can go from there. All right, here's the piston. Came out really nice. So next thing for us is gonna be wash this thing really good, clean everything, put assembly lube, install it back on the motor, and then we can continue assembling the heads and all the other stuff. So let me get started and go ahead and start with that. All right guys, so I wanted to show you what a 0.678 lift looks like. This is from JCS Performance. This is on Vaughn's 124 cubic inch twin cam. All right, so we got pretty far along here. So we have our cylinders, our heads are on, our S&S roller rockers are on, our Smith Bros push rods have been adjusted. We have our JCS Performance lifters on there. So it's all good to go there. So I did want to say that these heads are 07 through 17, and this is an 05 motor. So bolt pattern, everything's the same, so they would work. The only difference is we had to have S&S make us a manifold to fit these heads, and this is going to go with a S&S Super G. And an advantage of using these heads is they have automatic compression releases, so that's going to work very well with the compression ratio that we're going to use. So the cylinder and piston kit came with a 45 thousandths gasket. We wanted to bump up our compression, and we ended up using a 30 thousandths head gasket, and then we decked the heads to get the compression ratio, which is a 12.2. That's kind of what we're getting at. So what I'm gonna do now is take everything off and install our pushrod tubes, get everything going here with our breathers and top rocker boxes, and then we'll continue from there. All right guys, so we're getting along pretty good on this motor. So the rear's all done, rocker boxes, everything's already done, Loctite with our S&S rocker arms and stuff. But I want to take the opportunity to talk to you guys about this. We use these, we make these, we sell these, and we use them on all our big motor builds. These we call these rocker box spacers. They're made out of, I think, 61 aluminum, and then we sand them, polish them, and so we sell these. If any one of you guys are interested or having issues with your rocker arms hitting the top of your rocker boxes, this is the way to go. They look real nice, they fit really good. But anyway, thought I'd plug a little bit of a commercial there. But guys, what I'm gonna do next is finish this front rocker box. We're waiting for our Thunderjet to come in from Zipper so we can put the carburetor on, but we'll continue with exhaust pipes and all that stuff. So let me get started with that, and we'll go from there. All right guys, so this thing's moving along pretty good. We got the exhaust on. You guys know how I feel about these Road Rage. I love using these. We did remove the baffle and remove the fiberglass pack, reinstalled the baffle. I like these exhausts for many reasons. One, high quality. Two, stainless steel. But the main reason is that there are stepped exhausts. So you got one, the primary, and then secondary, and then the third one, then you go into your collector, then your muffler system. So anyway, on this other side, getting ready to install the Twin Tech this module. You guys know that I use these a lot on the twin cams, carbureted models. They are extremely well. You need these so whenever you dyno tune, you have the ability to fine tune your timing, your advance, everything. So this is the way to go. We have the Barnett system already installed. The aluminum shifter. We have the Baker chain adjuster, primary chain adjuster. So I like using these. A lot of people, say that they're pretty rough on your transmission, and it may be, but when you want something to work, put the power to the ground. That's the way to do it right there. Anyway guys, let me continue. I'm gonna put the primary on, put the twin tick on, and then start working on the carburetor, installing the Thunderjet. Alright guys, we just received our Thunderjet from JCS Performance. I'm a big fan of Thunderjets. They really work and they make a difference in my opinion. So we have the new SNSG that's been bored out, so the center's been bored, which is pretty neat because this is available now from SNS. A lot of us had to make jigs and bore them out before, but now they're available and makes things a little easier. So let's talk about the results here for Vaughn's 124 cubic inch. So this was the base run. This was 69 horse, 81 torque. This was in stock 88 cubic inch with CV carburetor. That's our air fuel ratio. Then we did some dyno tuning after the 124 motor build. This is a second to the last run. 136 horse, 142 torque. Lots of difference. You can see the difference right there. Quite a bit of difference. But then I decided to advance it 6 degrees and we did another run. We ended up with 143 torque horses, 143 horses, 149 torque. Huge difference. The only thing is when we advanced it, it got a little lean. So you can see where it got leaned out there. And our graph got a little crazy. But overall, it did extremely well. So I just came back from riding it out in the street. This cam has very good, manageable, low-end torque, horsepower. It's very smooth on the throttle, but then you roll on it and it just pulls real hard. So this is a Woods cam, really nice cam. Very impressed with it. This is the first time we ever used this cam. So this did very well for a 124 cubic inch twin cam motor. 143 horses, 149 torque. So anyway guys, thanks for watching. We will have more videos coming soon, so don't forget to like, subscribe, and follow on our YouTube and Instagram, Facebook. Thanks for watching.